These are solutions to Melham's Math 222, exam number 3. Number 1, f of x is x plus 2, x minus 1, x minus 4. The zeros are -2, 1, and 4. In behavior, when x is a super big number, plug in a million, you get positive times positive times positive. Y approaches infinity. So if I go past the last zero, it goes up. X approaches negative infinity, negative a million, negative a million, negative a million, negative times negative times negative, negative. And all the zeros are multiplicity 1, so they have to cross the x-axis each time. So this one goes to negative infinity, has to come up. This one has to go down, and this one goes up. Number 2, P of x is k times x minus 1, because a 0 of x equals 1 of multiplicity 1, x plus 3 squared, because you have a multiplicity of 2 of -3. And then it says P of 0 is 4, which means if I plug in 0, the answer is 4. So 4 is equal to k times 0 minus 1, -1. 0 plus 3 is 3 squared is 9. Divide both sides by -9. K is -4/9. So the polynomial is -4/9 x minus 1, x plus 3 squared. Number 3, by inspection, 1 works. If you look at the original polynomial, it's pretty easy to tell that 1 works. So synthetic division, 1, 1, 2, -1, -2. 1 comes down. 1 times 1 is 1, add 3. 1 times 3 is 3, add 2. 1 times 2 is 2, add 0. Remainder is 0, as you would expect. So P of x is now x minus 1 times x squared plus 3x plus 2. And then I recognize this factors into final answer of x minus 1, x plus 1, x plus 2. Number 4, the possible rational zeros, plus or minus a factor of 6, divided by plus or minus a factor of 4. Factors of 6 are 1, 2, 3, and 6. Factors of 4 are 1, 2, and 4. So I take each of these and divide by 1, by 2, and by 4, leave off any repetitions. So 1, 2, and 3, 6 divided by 1 just gives me plus or minus 1, 2, 3, and 6. Take the same 4 numbers and divide by 2. So I plus or minus 1/2, 2 halves, but 2 halves is the same as 1, so I don't need to repeat it. Plus or minus 3 halves, plus or minus 6 halves, 6 over 2 is 3, so I can cross that out. And then these same 4 divided by 4, plus or minus 1/4, plus or minus 2/4, well, that's the same as 1/2, so cross that out. Duplicate, plus or minus 3/4, plus or minus 6/4, 6 over 4 is the same as 3 over 2, so cross that out. So here is my entire list. Okay, number 5. Domain is all real numbers except for -1 and 3. You cannot divide by -1 or by 3. Intercepts 1, 0, and -3, 0. If I plug in 1, I get a 0 in the numerator. If I plug in -3, I get a 0 in the numerator. And 0, 1. If you plug in 0 here, 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 and here, you get -3 divided by -3, which is 1. And vertical asymptotes, x equals -1 and x equals 3. Horizontal asymptote y equals 1, because if you multiply the polynomials out, you get x squared plus blah, blah, blah over x squared plus blah, blah, blah. In the long run, it's x squared divided by x squared, which is 1. Number 6, vertical asymptote x equals -1. Horizontal asymptote y equals 0. When x goes to infinity or negative infinity, y approaches 0. So I have an asymptote at x equals -1. A little bit to the left, well, the numerator is always positive 3. A little bit to the left, I get a negative. Positive divided by negative is negative. Y approaches negative infinity. X approaches -1 from the right, like -0.99. You'd have positive divided by positive. Y goes to infinity. So asymptote here. Asymptote is the x-axis. You have an intercept at 0, 3. So graph goes like that and like that. Number 7, the thing under the radical greater than or equal to 0. So boundary numbers are -5, -1, and 4. They're all closed. -6, -2, 0, and 5. -6 here, here, and here gives me 3 negatives. Comes out to be negative, false. -2 here, here, and here gives me positive times negative. That's a positive. Greater than or equal to 0, that's true. Shade in region 2. Plug in 0, positive, positive, negative. Makes the whole thing negative. Negative greater than or equal to 0, false. And plug in 5, they're all positive. Multiply all positive, you get positive. Positive greater than 0 equals 0, true. So bracket -5, -1, union bracket 4, infinity. Number 8, x minus 3 to the 2/3 means cube root of x minus 3 squared. That means this thing can never be negative. Intercepts, I notice 3, 0. Plug in 0, well, the best I can say is 3 to 2/3, or you can say the cube root of 9. That's also okay. I plugged in some quote unquote nice numbers. If I plug in 3, I get 0. Plug in 4, I get the cube root of 1, which is 1. Plug in 2, 2 minus 3 is -1. Square root is 1. Cube root of 1 is 1. And the other thing I want to do is try to force this thing to be 8 or -8. Okay, if I plug in 11, 11 minus 3 is 8. 8 squared is 64. Cube root is 4. -5. -5 minus 3 is -8. Square root is 64. Cube root is also 4. So I plot these and it gives me this funny bounce over here. Okay, so there's no asymptotes. And the intercepts are 3, 0, and 0, 3 to the 2/3. Number 9, multiply by the conjugate of the denominator in the top and bottom, 4 minus 5i over 4 minus 5i. So the top by FOIL is 8 minus 10i plus 12i minus 15i squared. The bottom is 16 minus 25i squared. I squared is -1. That becomes 16 plus 25. -15 times -1 is plus 15 over 16 plus 25. 18 plus 15, 8 plus 15 is 23. -10i plus 12i, 2i divided by 41. Split it into 2. 23 over 41 plus 2 over 41i. At 10, you're given 1, 0 is 2 minus 3i. So x minus parentheses 2 minus 3i. That makes the other one x minus 2 plus 3i. And we're also given 4 as a solution, so x minus 4. Hard part is to work this out. Distribute the minus sign. It's x minus 2 plus 3i, x minus 2 minus 3i, x minus 4. So that's like a plus b, a minus b. So a squared minus b squared, x minus 2 squared minus 9i squared, minus 9i squared is plus 9. Multiply this out, x squared minus 4x plus 4 plus 9, that becomes plus 13. So x squared minus 4x plus 13 times x minus 4. Multiply it out, you have x cubed minus 4x squared minus another 4x squared plus 16x plus 13x minus 52. So x cubed minus 8x squared plus 29x minus 52, final answer. So these are solutions to Melham's Math 222 exam 3.